So my name is Dave Nielsen, and I work at Redis Labs, so let me get that stuff out of the way first. I'm a developer advocate. I've been doing this kind of stuff for a long time. My number one goal in my job is to help people, first know broader what Redis is. It's not just a cache, because that's what a lot of people think about it. And so today what I'm going to do is talk about kind of more than just what you can do as a cache. Because Redis, for those of you who have used Redis before, most likely use it as a cache or perhaps as a message queue or something like that. So out of curiosity, how many of you have actually used Redis before? Cool. All right. So maybe about 25%. How many of you really don't know what Redis is? Raise your hand. Okay, that's like close to maybe a third. Okay, so I'll make sure to cover that because we've got an hour. I'm going to make sure that we cover the basics and then hopefully a little bit more. And in particular, I'm going to talk about the data structures because that's, in my opinion, like the most interesting part of Redis. So that's that. And a little bit more just about the company I work for, because it is, I think, important to know, where and who you're hearing this information from. So Redis is a very, very open source project in that it's a BSD project. It's used for free by large numbers of websites, and including, anybody heard of them? Amazon Elasticache? Okay, they've got a Redis option there. Azure Cache also, and we start off as a company running Redis as a service, primarily targeting Heroku users. So as a plugin with Heroku, you can just click a button and all of a sudden have a Redis as a service for your application, all within that Heroku experience. And we are running it on Amazon. Eventually offered it to the Amazon users just directly, and eventually offered it on Azure, on IBM Software, and on Google Compute. So we actually run completely different deployments on all four of those. And then we also expose it into IBM Bluemix, which is a platform as a service. We also expose it into Pivotal's Pivotal Web Services, which is also a platform as a service, AppFog, AppHarbor, and OpenShift. So those are all kind of platform as a service that we offer this kind of click and deploy or click and use automated service. But that's how we started. And then by running Redis, I think we now have something like around 140,000 Redis databases as a service. We got the experience to actually, and we have to deploy it over and over again in the cloud. We package that up, make that available as software, and so you can have open source Redis, which is, again, it's incredibly free, no limitations on that, or you can get from us an enterprise software solution, which basically is the same exact Redis database, but all the management stuff, scaling, charting, high availability, backups, all that kind of stuff is provided, without you having to do much. So that's the company. We've been trying to do as much as we can for the community. I've been helping to start meetups and find speakers to go and speak about just Redis, just open source Redis. We're sponsoring RedisConf this year, which I can give you a free code if you want to go. It's next month in San Francisco. And we employ Salvatore Sanfilippo, the creator of Redis, which basically means he works on open source, and it's kind of a sponsorship in a way, but he's technically employed by us. So that's what we're trying to do for the community. We want to make sure that the community is healthy, because we know that our future is tied very tightly to the success of and the health of the community. So that's why I do these talks. Really, I'm going to be talking from now on just about open source, and that's it about the company. Okay, so let's move on. Do you have any questions before we get going? I'm happy to take questions as we go, but we'll see how it goes.
Okay.
Yes. Okay.
You mentioned Redis as a service, and I'm thinking, I was using Redis as a cache, but I don't know whether
Yeah, that's actually a really common question. I get this all the time, and so the answer is it depends, and here's why. Let's just take a very simple scenario. I just was at a hackathon in San Francisco, Angel Hack, okay? And this guy comes up to me, he's like, hey, I think I could use Redis. Okay, what are you doing? And he said, well, my application, the home page, makes 200 requests to the database to build the page. And I'm like, you could probably use Redis for that. So in that case, it wouldn't matter where you put Redis. Redis could be across the world, and that would be faster, probably, because that's a lot of trips. And your database is probably, if you have many users, it's going to get bogged down with that much. So if you think about just more of a typical use case of maybe 10 round trips, because that's actually not very uncommon. 10 round trips, let's say you're getting 100 hits per second, which is not that many, times 10 trips, that's 1,000 hits to your database, and you cache that for 1 second. You've just removed 1,000 hits to your database. So per one hit to Redis. So, or per, you were hitting 1,000 times, you're now hitting it 10 times per second, right?
It's not necessarily greatly increased speed and food, but rather taking some stress off.
Yeah, there's a lot of people who use it just to take stress off the database. And, there's a lot of reasons to use it, but that, I would say, is a very common, practical, not a lot of mental effort to figure out, that use case. So, it's a very common one, and, happy to do that. But Redis can do a lot more than that, so we'll get on. It recently changed the title, or the description of Redis. So it used to be referred to more as a key value store. You can still think of it that way, but a more accurate way of thinking of it is a key data structure store. And what I mean by that is a typical key value would just simply have a key and a string of some sort, or maybe a hash or something, but it's basically just this one string. But Redis has lists, sets, sorted sets, and other things which really are in lots of items attached to a key. So that's not a key value, it's key multiple values, and then on top of that, those are different structures, each one of those. So that's why we call it, and refer to it as a key data structure store, or just a data structure store for short. And that's now the official description of it. And as I said before, it's very commonly used as a cache. Its original use case, and still a very good use case, is as a message broker. And you can use it because of all the data structures. You can use it as a database. Depending on what you're trying to do, it can be an incredibly fast database. I wouldn't say it's for every possible database scenario, but maybe half of them or something. It's a very good database. Yes, hand in the back.
Can you elaborate on what you mean by message broker?
Yeah, sure. I think I have a slide on that later on, but I'll just go ahead and answer it now. Why not? So the original use case, as told to me by Salvatore, was that he was working for a telco in Italy, I believe, and all he was trying to do is gather metrics like hits to a page, right, or to the website, probably many websites, because he was getting so many of these hits that he was not able to throw them into MySQL. So MySQL was not able to keep up. And I think he went through 2 or 3 deployments of MySQL trying to configure it different ways, and he just couldn't get it to work to keep up with that much analytic data. So he said, well, I'm just going to throw this in a memory, and then I'll do like chunks of dumps into MySQL at a time, which is a much more efficient way of using MySQL. So, and that way he can capture everything in memory. So that was the very first feature that he created, and it literally was a key with a list of values. Yeah. And so, but think of this, is that like that is essentially a message queue in a way, right? And it has since actually been used very effectively as a message queue, because you're just throwing items on, like I always think of it as top to bottom, but it's actually, the way he thinks about it is left to right or right to left. So you're always adding items to one side and popping them off the other. And that's how it works. Yes?
I've seen that sometimes like added a few.
Yeah.
You get a lot of discussion about that? Or?
Yeah. So it's interesting because RabbitMQ is obviously dedicated to messaging.
Yeah.
Redis is not dedicated to messaging. So it depends on what you're trying to do. If you really are just trying to move data through quickly, and in memory is fine, then Redis is a great option. I read some very detailed analysis of somebody who I believe was unbiased, and Redis is not quite as fast as RabbitMQ, but it's very close. It's like 80% as fast, something like that. So if you're looking for like just a dedicated job and you want to persist those values as they're going through, then RabbitMQ might be better. If you're looking to combine other things, because Redis has all these other capabilities, and in memory is good enough for you, then Redis is probably a better option. So yeah, it just depends. There's a lot of movement now around MOM, message-oriented middleware, and so you'll see Redis used in that way as well. And now I just read something about MEQQ or something like that. It's like an Internet of Things library that kind of handles messaging, and then you could use Redis as a backing for that. So, and then of course, what's that? MQTT, that's what it is, yeah. Okay. Okay, so there you go. This is just some stuff to let you know that, hey, we're number one, depending on what week of the year. It's a very popular database. That's what we're trying to say here. It's very well liked. It's very popular among SQL users. It's very popular among container users. It's very popular among developers. So, good for us. And it's also used by a lot of the social media websites. Kind of started using it heavily. Twitter was probably the first real big user of it a long time ago. And you'll see it used by most of these. Most of them are using it as a cache. However, some of them are not. So, it depends on the situation. For example, Pinterest uses one of the data structures called a bit array, which is literally like a string made out of bits. Each one of those bits is addressable, so you know exactly where that bit is, and you can go and find out whether that bit is flipped on or off. And each one of those bits could represent the online or offline status of a user. So if you wanted an extremely efficient in-memory way of tracking the online or offline status of hundreds of millions of users, you could put that all into memory on one server with a bit for each one. And so Pinterest does that. So when you log in and you have like your 20 friends on the right, and it shows the green or red button or whatever, the icon, let you know if they're online or offline, it's making a quick call to Redis, getting that back and showing that value. So that's one way you can use Redis. And do they need to track that by persisting that value to disk? I don't know. Maybe they do. I don't know, but they don't have to, and they can just keep that in memory, and it works great, right? Okay, so used by lots of folks. Even a company who supplies their product, Alcatel-Lucent, to telcos, they're using Redis. I believe, and I don't know this for sure, but I believe it's to track sort of the metadata about a call. So during a call, like what's going on, all the information about that. And so having an inexpensive, high-volume way of tracking all that metadata about calls is a very effective and useful way to use Redis. I don't know much more than that, but I know that they're using it. And then all these, you've heard about all these unicorns. Hooray, unicorns! They're not doing so well lately, but apparently a lot of them use Redis. I would recommend that the cockroaches. Have you heard about cockroaches? Startups that are focused on actual revenue. Ones who can survive the nuclear winter that is coming from the unicorns. Okay, they should be using Redis too. I'm sure they are, but I don't have that logo. They don't have enough money, I guess, to. They're putting all their money towards customers, not logos. So let's get on to the main topic here, which is what's inside of Redis. Anybody even know what this particular image is from? Was that 3001? 2001? I think, because I kind of just grabbed this off Google Images, I believe this is actually from 2010, but they're referring back to 2001. I think that's what's going on there. But yeah, just like when you look inside, when you look inside the monolith and saw all these stars, like when you look inside of Redis, you see all these data structures, and it's pretty cool. It's unusual. Most databases don't have lots of different data structures. So what are the data structures? Here you go. Let's start off here. As I mentioned, like the first structure that Salvatore created was lists. So I'll get to that in a minute. So let's start with something very simple, and that is just the key value typical standard use case of a NoSQL database. So in this case, you literally have a giant index in Redis of keys. And you get to name the key. So you call it whatever you want. You just tell Redis, I want a key called, I don't know, user:1. Right? I'm going to say user:1 because it's actually a very good idea because all of the keys are in the same namespace. It's a very good idea to give all of your keys sort of a prefix. Okay, so user:1 is the prefix is user. Colon separates the prefix from what you really want to call your key, which might just be user1. Okay, but you don't want to call it 1 because you might have product ID 1, right? Or you might have session 1, or you might have, I don't know, product ID. You know, I already said that, but company 1, right? So you don't want to just call it 1. When you give it a prefix that's unique, that's basically defining its own namespace. But this basically means that Redis is just this giant index of all these keys. And so when you say, get me something, it just has to look into one index to find the key, and then it grabs the value associated with that key. So extremely fast, right? There's no like looking up to look up, right? Just one stop. That's what makes most of these NoSQL databases so fast. And with the string, it's very simple because you look up the key and then you get a value, and that value is a string. They can store numbers and things like that in there, but it's essentially stored as a string. Okay. So, very simple data structure. Just for fun, let me switch over here, and I'll just show you. So if I do a Redis CLI ping, okay, I get pong, that just kind of tells you that the server is there. All right, and what I've done here is very simple. You can do this yourself. You know, in Ubuntu, just sudo apt-get install Redis. Just download. You've probably done that, many of you. Update, okay, and then you get what I have. That's all I've done so far. And you start the server, and you've got it running. It's in memory, so when you shut it down, you basically don't have most of your data running anymore. But that's okay. You can start it back up. And you can persist. So you can default it to say, save my data to a file, and then it starts up again, you'll have your data back. So, but right now I have nothing in here. I think if I go and do the command Redis CLI and I do keys, I think, oh, okay, I still do have some, that's from my previous demo, okay. So I've got some keys in there, but a very typical starting mode would be Redis CLI set, and then just put something like foo bar, okay? Tells me that worked, and then I can say get foo, and there's bar. So see how simple that is? And this works basically because it's a function-based database. You don't write queries or anything complicated like that. Everything's a function. So I just simply call the function called set, and I passed it in a variable. I'm sorry, I passed in two variables. The first variable is foo, which is this is the key that I would like you to create, and then bar, here's the value. That's it, very simple. And then the second function is called get. Get foo and tell me what it is, and the result is bar. So very, very simple. I'm going to come back over to this website. So this is because I'm on such a smaller screen, it thinks I'm on a mobile, by the way. So that's why it's missing the top part there. But if you click on this little mobile thing here and click on commands, okay, you get, again, it's kind of a different view than I'm used to, but you get a list of commands, and there's a lot of them there. If I can filter it by data structure, so let's go to strings, okay, and then let's see. Oh, it did, okay. Well, let's see, it should still be in there, right? There it is, okay. So let's go take a look at set. And it gives you an explanation about set, tells you a little bit more about it, and it usually gives you some sample. This is the command line example. not specific to a programming language. So this is what you would type from the terminal, and it works pretty much as advertised. In fact, that's almost exactly what I got. It's a different key and value. The website's great, by the way. I find it incredibly simple. Sometimes the language is a little bit, I don't know, mathematical or big O notation. They give you some explanations there. So if you've read big O notation before, it probably seems pretty easy to understand. But for the most part, it's really easy to understand, and I strongly recommend just checking it out. It's literally this easy. The only thing I've done that you haven't seen right now is just download and install Redis, and everything else is pretty much exactly what you've seen so far. So very easy to get started. Let's go back to presentation. Okay. So that was strings. Now hashes. How many of you have used hashes before? Okay. So hash, again, is a key. And then there's a string basically in there, but it's chopped up into field and values. So you can kind of use it like you might a row in a table, kind of, right? Except for each value, each hash, you have to actually store in that hash the field name with the value. So whereas in like a typical table, you kind of define the table structure with the field names once, and then you don't really worry about storing the field name over and over again in each row. Well, in Redis, you do. So you're storing the field names with the values. And so, it's a little bit extra work, but the result is that you don't have any overhead that has to be looked up to get that value. It's right in there. You go key, field, boom, you're done. Right? So extremely fast. Again, with a focus on being fast. That's the purpose of Redis. So let's do that. Let's go take a look at what that code would look like. So here, I might say h set, and then what I'm going to do is let's do fname. User 1, and then fname. Let's do Dave. Okay, so again, see what I did here is the key is separate from the field names, right? I can have multiple field names. So I made sure the key had user : 1 in there. So now I've defined, it's sort of a convention, right? It's not configuration, it's convention that I'm using this prefix of user. And then because it's a hash with multiple fields in it, I also have to define the field name, right? Which I put as fname, right? And it's really funny. I just did this demo 2 days ago in Seattle, and at our first Redis meetup in Seattle, and I was using the Redis cloud, which means I'm typing in the IP address and the port, and somebody was following along in the audience and did exactly what I was doing, only they had used their name. So immediately after I did Dave, and then I went to go do this, I went to say, well, okay, now I'll see you can get the value back. And it said Caitlin. and I had done it so fast, like there literally was no more, it was 4 or 5 seconds between the two, because I just went one for the other. And it said Caitlin, and I was just like, jumped back, because I was like, what? How is that even possible? She had just been following right along, and as soon as I hit enter, she hit enter, and boom. So that was nice, fun surprise. So, yeah. So right now, what I'm doing is I'm typing the command. I'm using the terminal. The way it would default to is look for Redis on your local machine. Okay, just for fun. I don't want to type the whole thing in again. There we go. Okay, here we go. So, typically what would happen if you were going to talk to a remote server, you're going to put -h, and then that's the IP address or the URL to where that server is located, and then -p for the port, and then that's my, everyone can see password, deep blue. I'm telling the world, apparently. So if you ever want to try hack anything I'm using, you think I might have done just for fun, keep my password. So that's how you would typically connect to it through command line if the server was not on your laptop. He was first, so go ahead.
Just real quick, does the date give an example where there's now like transactional locking in Redis?
So it's actually impossible to have locking because it's single-threaded, which comes with strengths and weaknesses of being single-threaded. The nice part about single-threaded is every operation is essentially unblocked because there's nothing else going on, right? And that gives it the ability to actually go very fast for that one thread, and you don't have to worry about blocking at all, ever. Obviously, you could have multiple clients hitting that database, and one might write, and then another client might write, and then you might read, and it's been changed. But that's just the nature of the beast, right? That's not anything surprising, really. But as far as and you can actually wrap your commands in transactions so that you know that a certain series of transactions are going to happen in a row with the command multi. So you can actually make sure that you know these certain commands will run before another client hits the database. So you can kind of have blocking, sort of, I guess, but I wouldn't call it that.
So that's quite a bit different to say Postgres.
Yes. And and it's, again, I'd say it's a strength and a weakness. It helps Redis just be blindingly fast, but you live with that limitation that it's not multi-threaded. The way you get around that limitation is if your server has, let's say, multiple processors in it, you would then install multiple shards of Redis. So you're going to take full advantage of the processing power, but you now have a sharded database. Okay, that's how you get around it. And you can set that up yourself. It is one of the things we just do out of the box with the company and our cloud version. Both just do that out of the gate. I think I've answered that. Okay, did you have a question?
I did. I know of a second. Are you going to show us how there are other programmatic ways to interact with this? I mean, for example, if I wanted to pull and set things on a bash script, local or remote, would I do that and drop it in a variable? I see with some of the APIs, Python, maybe how you call it, set any of that look like?
Kind of. I can go through the library. Let's get to that and see if I can show you something like that. I hadn't planned on doing that in this demo, but there's so much to cover even before I get to that. But the first answer to your question is that there's really no such thing as setting a variable on the server. You can use Lua scripting, but even that's really not going to save any sort of state on the server. If you want to save state, you put it in the database somewhere in the data structure, and that's where you store the state, but not in the language itself, if that makes any sense. So Lua is not going to save it itself. But Lua is how you would expand Redis capabilities, beyond the 180 commands that there are, and you can actually even do SQL type things with that if you want. There are some plugins or Lua libraries that actually give you SQL type capabilities, and there are client libraries that work with that give you that capability. I'm not sure that's depending on what you're trying to do, right? Like sometimes that makes sense, but if that's mostly what you're doing, there's Postgres and other ways that easily do that. Redis may still be faster, but you're doing sort of convenience against performance. In that case.
Okay. Follow-up too.
Yeah, sure.
Not even related, but you brought up sharding.
Oh yeah.
I saw something about clustering on the first screen as well. If you have native sharding set up for clustering, I mean, do you have to set that up manually, or does just magic happen and it all talks to each other?
Yeah, not a lot of magic is happening. So there's two ways to do it. What happened was, and I don't know the complete story here, but when Redis first started, you had just Redis, the database, and then they came out with an open source project, came out with something called Sentinel, which gives you high availability, so it monitors the instance and then relaunches it and rebuilds it if it fails. And then there's Redis Cluster, which is the ability to deploy multiple Redises, and then you can combine that with Sentinel to give you sort of a cluster that's highly available. And then you can, of course, set that up so that it's persisting to disk, so you can recover from disk if failures occur. And this is all something you're going to set up yourself with the open source code. Now, our co-founder, CTO, comes from a load balancing world, very much understands high-speed communications and clustering and all that kind of stuff. So when they first started running Redis as a service, they wrote their own code to do all that. And so we kind of have our own proprietary way of doing that. And so we do all that stuff, got to update my backup. I switched machines recently and didn't actually switch the backup package. So the point I'm just trying to say is, like, we kind of have our own proprietary way of solving that, but you can do it in open source as well. But it's not plug and play.
Thank you.
Yeah. There are people working on that kind of stuff, though. So, there's a community of people who are actively working on Sentinel and Redis Cluster. Okay. All right, so we showed you hashes, and we talked about lists briefly earlier, but lists, again, is a key, and there's a value, but you can actually have multiple values. And you're basically creating a list of these values, and you can add to the right or add to the left of that list, and that's how you end up with a queue mechanism. And I'll come back to that in a minute. Sets, again, I kind of think of them more vertically. So you have your key, and then you just have a set of values. And what's different about set is that all of those values per key are all unique. So you cannot, it's physically impossible to add a duplicate. And what happens is if you try to add a duplicate, it just ignores it. That's a benefit. That's a feature, not a bug. Okay? And the reason why that's a feature is if you are trying to store unique IP addresses visiting your website, you just throw them at set, and it ignores the duplicates. And there's a lot of reasons why you might want to do that. You might want to be storing all sorts of things like unique product IDs, or perhaps the pages that a visitor visited. You don't want to store the pages twice. All those kind of things. There's many, many reasons why you just want to have a unique set. And you just throw it at it, and it takes care of eliminating the duplicates for you. So it just ignores it if there is one already. And then there's sorted sets. Okay, sorted sets is very much like sets, except for there's an additional column so each key has multiple values, and each value has an additional value, which we call a score. Okay, so you kind of think of it like there's two columns in the sorted set. So the easiest use case for this would be, let's say you're running in a mobile game or a massively multiplayer online role-playing game or something like that, and you've got, let's say, tens of thousands of active players, and you want to track their score in real time. So every time they do something that generates a score, you want to track that. And then you also want to be able to display that in real time as well. So you can imagine if you were blocking, how this could create some real issues, right? So this is a really good example of where doing it in memory and not blocking fits really well with Redis. And what's going to end up happening is you just simply pass in the gamer ID, and you can either pass in a score or you can increment the score. Okay, pretty straightforward. And when you do that, if you're adding a value, if you're adding a value with the score, it's going to then find its place in the sort order, and then now you'll have that value in its score. And then, or if you're updating a value, it then quickly sorts itself and puts itself in the right place. So now when you're reading any of that data, there's no querying that has to happen. You're just pulling it right out of memory by finding a location and then choosing a section of that data to view. Okay, so it's extremely efficient. You can use this for a lot of things. I believe a company like Netflix, I'm not sure if it's actually Netflix, but they store their top API error messages this way. So every time an error message comes in, they store that as the value, and then they increment the score by 1, and then that gives them like the top error messages. And since they have like, literally billions of API calls per day, they get lots of errors, and they can see what the top error messages are in real time. Right? Okay, so we'll keep going here. Now, these last 3 are a little bit more advanced. So they may not be where you start, but a bit array, like I said before, literally is a key with just a long string of bits that are addressable. So you can go and see, what's in there. Okay. There's a lot of different ways you can use that. It kind of just depends on what you're trying to do. Yes, in the back. Yeah, it's big. It might be like 256, at least 256 megs. I mean, it's big. It's probably bigger than that. It might be even like 256 gigs. I don't know. It's some big number though. It's probably in the gigs. Yes.
Is it continuous or sparse?
Good question. I don't know the answer to that. Good question for me to go look up though. So if you want, I will follow up with you on that. Just see me afterwards and I'll follow up. But somebody asked me that earlier and I have not looked it up yet. So I believe it's continuous, but I don't know. So Bitaway, I gave you that example earlier about storing every user's online or offline status. So it's a very efficient way of storing that kind of information. The next one is a hyperloglog. Hyperloglog also is flipping bits. Okay, so it's similar in structure, but what its purpose primarily is to store a statistical count of some long number of things. So how many times does a particular word appear in a large amount of text? Okay, it can do sort of a statistical count of that by sampling it and storing that in a very small amount of data. And so instead of having like a terabyte of text that you're going to go search through, it can store a statistical count of that data in memory in like 14K. Okay, so it's a much more condensed way of storing an estimate. And if you ever wonder why you would want to have an estimate, let's go take a look at Google. And let's take a look at Redis. And you see this right up here? It says that there are about 11,800,000 results of the word Redis on the web. Do you think there's exactly 11,800,000 results? Do you think there's really an accuracy of, what is that, five zeros? Probably not. So they are doing something very similar. Maybe they're even using the hyperloglog model themselves. I doubt they're using Redis to do this, because Google likes to do everything themselves, but this is a good example of how you might use that. Okay. All right. All right, so my favorite one, Geospatial. This one is definitely going to be popular. It's still not quite in GA, although it is expected to be in GA this month, if not next month. So in the next month, it should be in GA. You can download it. It doesn't come in the default download, but if you download 3.2, again, from the website, it does have Geospatial in there. And you can kind of guess what this is, but it's very simple. It's storing latitude and longitude, essentially, together in an index. And then when you're searching for points, you can search for what points are nearby based on radius. Okay, so it's what you would think, I believe, Geospatial would do. And I think this is going to be very popular because of all of the social where are things kind of stuff going on. Everyone wants to be the Uber of this, the Uber of that. I think that'll be very popular. Yes?
I know I can't remember the actual name of the standard. I know SQL database has is it just flat line pairs, or are you allowed to define regions and states and boundaries and lines?
Yeah, I don't believe it has shapes other than a circle. So radius, I believe, is all it has. There may be ways you can handle that with client libraries. Well, maybe there is something in Redis that I don't know about, but I don't know of anything more than just a circle.
Okay, that wasn't actually talking about the search radius,
Uh-huh.
but the actual object itself.
Oh, storing the... Yeah, I believe it's only storing a point. And I believe I heard the story that the way it's working is that you take your latitude and longitude numbers and you basically intersperse them so that the first lat and the first long, then the second lat and the second long, digits. And then what's useful about that is when you're searching, you can specify how many digits you want to search by, and then that helps you. The fewer digits you search by, the faster the results, but the less accurate. The more digits you search by, the slower the results, but the more accurate. I believe that's how it's working. By the way, I don't know if this is a standard or not, but I believe sort of like the default way you do lat and long, perhaps, I should look into this more, is if you would just use one number, you just passed in one number, you passed in a 1 or a 0, I believe the way that works is you are going to get back, oh, it's this half of the world or that half of the world. So you could do that, and you can maybe do it by hemisphere or something. So anyway, I believe that's how it works. This is not my area of strength. It's a new thing I'm still looking into. But I've already kind of written enough code to see that you can easily do, you can add your locations, like a bunch of points, and then you can search, let's say, choose one of those points and then do a radius search and it'll return the points. So that's the main thing it's doing. If you want, you can then do that in sort of a pub sub sort of way so that you're storing the current locations in Redis, and then every time something changes, you can push that out to your clients, and that's, if you ever use Uber or something like that, you see the cars move around, that's essentially what they're doing. All right, cool. So let's keep going. Oh, and as it says below, it says data structures are used like Lego building blocks. And this is very true. Because the individual structures that Redis has are so simple, there's not a lot of extra data there, there's not a lot of extra structure there. Each one of these structures is extremely sort of limited in its complexity on purpose so that it can be extraordinarily fast. Sometimes the capability you're looking for doesn't exist in a structure. You can combine it with another structure and you can get that capability. A very simple example of that would be if you wanted to have an index of a bunch of values. If you were storing a bunch of, let's say, products, for example, and you had a product ID and you had, let's say, a product name or something like that. Let's just stick with product ID. So if you wanted to find, if you're storing them in a hash, because a lot of times you store lots of data about one particular item in a hash. You can even store, by the way, JSON it stores it as a string, but you can convert it to JSON and store it in a hash. You can even store arrays, so in a hash, in a field. So you kind of have what amounts to as a one-to-many relationship, but it's all stored inside that hash. But you might want some sort of index so that when you're searching, it comes back faster. So what you might then do is take those product IDs, put them in a sorted set, right? Because the sorted set would then simply have, the product IDs actually sorted, not by number, but by text, right? And then you'd be able to find it extremely fast. And then the other value would be the ID of the hash, right? So then you can sort real quick, find by product ID, and then go get the ID of the hash and go look that up. Okay? That's one way to do it, at least. Yes.
So, for example, you were asking about the shapes earlier. You could correlate geospatial indexes and sets to create a custom set type.
Yes.
For geospatial shapes.
Yeah, this is very common. This combination is extremely common. Or you can combine it perhaps with lists. For example, if you want to have pub sub, you want to have lists of items that browsers are listening for. I'm listening for a change of this particular car ID, and then you have a set of all of the browsers basically that are listening to that, what they call a channel, right? There's lots of these combinations that you'll find. Okay. So you might combine these. And one of the real nice things about Redis is that everything's happening at the server. So, like, everything's server side. There's no, there certainly are times where you make round trips, but the intent is for there to be no round trip. So you're constantly finding that there are functions that allow you to do things. Like, for example, there's a function where it says, if the value does not exist in the sorted set, don't add it. Right? So looking to see if it's there. If it's not there, don't update the value. Right? Don't add the value. Right? So there's those kind of functions that are extremely efficient, and there's a lot of those kind of custom little functions that are slightly different based on the behavior you're looking for, so you don't have to do the round trip. Okay. All right, so what I'm going to do with the remaining time is I'm going to go through some use cases and show you the commands that you might use for those use cases. And again, just before we go any further, I'd like to explain that there's caching is a very popular use case, which I'm not really going over here. Message queue is a very popular use case. I will briefly talk about that here. But because I left caching out, let me just explain that real quick, because I think that, especially this audience, you're probably going to end up with that use case often. Very, very simple. What you do is, again, you're probably going to use either a string. A string works fine with caching, by the way. Well, it depends on what you're storing, but string can work really well. All you're going to do is say, hey, this part of my web page requires me to hit the database one or more times, or maybe there's some complex routine that you have to run that takes a lot of time, like a rendering or something like that. And you say, you know what, that takes so long, and I don't have to absolutely have the latest value. And if I do, there's a workaround, by the way. And so what I'm going to do is I'm going to cache the result of going to the database and getting that value. I'm going to stick it in Redis. And the way you use that is in your code, or whatever language you're using, Java, whatever, you would say, hey, Redis, does the ID for this part of my page, does that exist in Redis? And if so, give me back the value, and I'm going to put it in the page, and I'm done. I'm going to return that to the user. Right? That's a cache. If you return a, no, I don't, the value does not exist, then you go to database, you get the data, you build whatever that string or part of your web page is supposed to be, you put that into Redis, get that key value, and then you return it back to the page and build the page and respond. And then the next time the request comes in, hey, Redis, is that there? Yes, it is. And you don't have to make the trip to the database. So it's actually very simple. I should put this in a page. I don't know why I haven't done that on a slide. It's very simple. I should have a slide for that. So note to self, add a slide for that. Anyway, so that's how caching works. Very simple. There are ways you can set, there are ways you can tell the database essentially to have the value expire. You can actually set a time to live on the value as well so that it automatically expires. Redis, every time Redis goes through its loop, it checks to see if values it expires and deletes them. But even if it hasn't found them yet, it ignores the keys that have already expired. So even if it's still there with the key, but the value is expired, it will ignore it. Okay? So Redis does some cleanup, but that expire value is attached to that key. Okay, so anyway, let's move on to some other use cases. And let's start with user sessions. User sessions, I'd say beyond regular caching, user sessions is extremely popular as well. It is kind of a caching scenario, but it's not exactly because you're also using it as a database. Caching, what's happening is you've got, generally the reason why you would use Redis for caching is you've got multiple web servers, so your application requires you to have more than one web server. In that case, where do you store the session information? It doesn't make sense to store it in the individual server because what happens if the load balancer sends a request to the second server? The session's not there. You could use sticky sessions with the load balancer, but that's not really a preferred way to do it these days. So, because you can end up overloading one server easily. So, storing that in a Redis database, even if Redis isn't on your web server, even if it's on another server, is still a preferable way of doing it. Well, you'd have to do it in that case so that both of those servers can get the same session information, right? Okay. So we're going to use the hash for this. This is the hash data structure. The reason why we do that is because you don't want to just store the user ID and are they logged in or not. You want to store other information in there as well, such as their first name, their last name, their username, the URL to their profile photo, maybe a hit counter that tracks how many times they've hit your website during this particular session. So there's a lot of information you want to store there. A hash is perfect for that. It's got the field and the values, and you can store quite a bit of information there. So that turns out to be great. You can even store things like if you're doing a social network, you can grab out of the database a list of all of their friends, stick that up into an array, store that in the field, and now you've got an array of all of their friends, their places they've been, the products they like, photos, all that kind of stuff can all be stored in the hash. And as I showed you before, you can use hset and hget to set the data, to get the data, and then you can use hincrement_by if you want to, say, update the field that you're storing the hit count in. Okay? Hincrement_by just simply goes to that field, that goes to that location in memory, looks at the number, and increments it by the value you specified. So, very simple to use. In fact, there's a lot of plugins for most of your open source projects, whether it's WordPress or Drupal or any of the projects out there, typically have some sort of plugin that's doing this automatically for you, so you don't have to actually write any of this code. Okay, so let's take a look at what commands. Again, I showed you before the hset and hget, but that only lets you specify one field at a time. If you want to specify more than one field at a time, use hmset. Okay, Salvatore sort of has his own naming logic. So H, I'm sure, is for hash, M is for multiple fields, and then set would allow you to pass in field value, field value, field value, and for a particular key. Okay, so you can see user session :1 would be the key name, and then you've got field value, field value, field value. Okay, and don't forget, if you want to delete a field, you can do that with hdel, but that only deletes a field in the hash. If you want to delete the entire hash, use del. So del, okay? All right, so let's keep going here because I don't have much more time. Let's take a look at Hughes. Hughes are very simple. They're stored in a list data structure. It's a key. It's simply a list of values. You can kind of think of it like a linked list where each value knows what the next value is, and that's about it. Right, so not a lot of indexing or capabilities there. You can go through the values if you'd like in the list, but it's going to take n amount of time to find the value you're looking for. So typically what people will use, though, is you'll use lpush function to push to the left side and rpush to push to the right side. And guess what? There is a function called lpop and rpop to pull the values off of left and right. And there's even really cool functions like rpop lpush to pop off of the right side of one queue and push to the left side of the second queue. And that all happens at the server side, so you're not worrying about, did it complete or not by, returning the value after popping it off to one side, and then you make another round trip, and you get an error message. Now what happens? The value's not transferred yet, right? So here's an example of commands. You'd say, Okay, we're going to do L push, L push, L push. We're going to pop orange, green, and blue to the left side. And then, ooh, I need to highly prioritize red, so I'm going to go ahead and R push it to the right side of that queue. So that's Q1. And now we've got Q2, and what I want to do is I want to R pop, L push to pop red from the right side of the first queue and push it to the left side of the second queue. See? Pretty simple. And this is very efficient and very fast. Okay, so let's keep going because I'm running out of time here. Real-time recommendation engine. Now, if you have ever been to like Facebook and you see that there's like you go to a profile of a user that you've never ever seen before and it shows you who your mutual friends are, you ever kind of wonder, wow, that's kind of impressive. I don't know how they do that. Like, well, what they're probably doing is they're taking that person's set of friends and your set of friends, which are both effectively stored in lists, and they're doing a join, an inner join on that to find the mutual friends. Okay? And the way we do that in Redis is by taking two sets of similar data and doing an S-inter, which basically is set intersect, that lets you see what are the common values in these two sets. Okay, very quick and very efficient. You can actually pass in multiple sets in, let's say, 10 sets, and it'll find the common values in those 10 sets. Okay, it's a very, very quick and dirty way to do a recommendation engine. You can imagine a WordPress or Drupal page where you have an article with tags, and you want to know what other articles have those similar tags. You would have a set for each one of those tags of articles that that tag belongs to, and you do an S-inter on the tag and find the common articles. Okay, very, very easy way. All right, so this is how you do it. I don't have time to go through this, but you can see the example here. I'm happy to share my slides. And let's get on to the last one, which is leaderboards. And this is the sorted set. I've already given this example earlier, and so I'm going to skip right to the code example. Here you can see where in line 1, I've got user ID 1 with a score of 11,000. And then I've got user 2 added, user 3 added, user 4 added, and then I'm going to go ahead and update user 3, and you're going to see that it's automatically going to change its location in the leaderboard. Or you can also do not just manually changing it, or not explicitly setting the value, you can also just increment the value. And then you're going to choose a range. You pick a particular user, and you can get a range around it. You know, which scores, users and their scores are around that particular range. Okay. So I'm going to wrap things up here. Let me share some takeaways for you. First of all, Redis is in memory. It's never grabbing data off a disk, ever. It might save data to disk only for the purpose of recovering from the disaster, or if you want to persist the data so you can maybe transfer it to another server. So you can persist the data, but it's never like requesting from disk when you request data from a data structure, ever. It's always in memory. And each of these data structures are very simple to use. They don't take much time to learn at all. Maybe some of the last three do. So you combine them like Lego blocks, and that's the main way to use Redis. There is clustering, there is persistence, there is high available. These are all built into the open source project now, so you have that available. You set it up yourself, but it's all there, it's all available. And last but least, I highly recommend you check out the Redis.io website. That's the open source project website. Lots of great information there. On our website, we have a great ebook. I highly recommend this ebook. It's written by Dr. Josiah Carlson. He's a passionate Redis user, and he's written a book on basically best practices on how to use Redis. It's not hard to read, but it is very detailed and accurate. We are happy to give you, anybody who goes to our website, you can get a free Redis as a service database on any one of at least 4 clouds, plus some platform as a service environments like Heroku. So feel free to take advantage of that. We have a trial for our software product, and we call it our Redis Labs Enterprise Cluster. That's a free pitch there for our product, complete product. And then finally, RedisConf is coming in for just under a month. Well, actually, I think it's like 3 weeks now. So if you want if you want to go, it's DSConf16, and that'll get you in free. We've got 2 days worth of 3 tracks. I think probably about 30 plus speakers, all speaking about either using it as a developer or in operations. So we've got about equal amount of talks in either. And on top of that, there will be a very cool announcement there. So even if you don't go, be paying attention to the Redis news around May 10th. Probably top 5 ever news announcement about Redis will be happening. So very, very cool. That's it. Thank you very much. Here's my contact information. Thank you for having me.
You mentioned the user group in Seattle.
What's that?
You mentioned the user group in Seattle.
Yeah.
Do you happen to have the name? Or
Yeah, it's Seattle Redis. So
Seattle, I can find them in Meetup.
yeah, meetup. It's Seattle Redis. Absolutely.
Okay, all right. Thanks.
You bet. Oh, and I've got stickers if you want them. Only through Salvatore. So he's doing that, and